So, thank you for joining the final event of the Smart5Grid project. It's a pleasure for me to have you here. And let's start with the agenda for today. So we will open talking about the vertical. Smart5Grid is a project dealing with 5G technology in the vertical of energy. So we will first see all the aspects related to energy industry in connection with the digitalization. And then we will move to the telco area and the challenges for this industry. After that, we will go through an overview of the project. For those of you who doesn't know about it, this is the moment to learn more about what has been our goals and how we were tackling them. Then we will enter in detail about the platform. I'm going by heart. I don't have the yeah, it's here. Talking about the testing facility for developers, and then we will go through all 4 pilots with a bonus track, as they say in media. We will have an external stakeholder who used our platform to develop a parallel pilot. And after that, we will talk about the next steps after the project ends. So let me call my colleague, Viviana Vitto, head of market strategy and regulatory analysis from Enel Grids. Thank you, Viviana.
Daniele, and thank you so much. I'm very honored to be today with you and to start, let's say, give you the perspective in particular of how, let's say, digitalization and telecom could join effort to transform the network for the future. So this is the scenario that all of you already know, but just to remind everyone the incredible efforts that we need to face in the following years, in particular on the perspective of the electrification of consumption and on the perspective of how many and how fast will be the needs for additional RES connection that will be joined the network, in particular the distribution network, because the amounts of renewable, this is the global view, but if we look at the European, is even higher. The volume of photovoltaic and wind that will raise a new challenge for the distributor. And this is the future, but already in these recent years, the growing request of connection is more than double and triple for the distribution network operator. And this means that not only the gigawatts added on our network will be incredible, but also the numerosity of players means thousands of new prosumers or generator that will determine the necessity of a different modality of operating the network, of planning the networks, because it's a question of how you need to understand how this distributed generation will move and how will interact with the network. This will generate also a needs for renewable expand and in terms of volume of investments. And if you look also to the scenario, again, the share for the investment related to digitalization is increasing over the year. This is because the network and the digital structure will be not anymore a separate, let's say, but will be a wall. So here we still see amount of digital, but I'm sure that in few years there will be not just the distinction in between which investment are related to digital network and which investment are related to the refurbishment or to the physical structure, because the network will be not just a pilot smart grid network, but will be entirely a smart grid. So we only speak about a single layer, let's say. Below is the commitments in terms of scenario of the needs of that is constantly driven from our side, and this is the recent Capital Market Day perspective that we have for 2024 to 2026 on our global network. It is related to Europe and Latin America, and the portion that is related to resilience from outside and digitalization. When we speak about quality and resilience, there is a conjunction in terms of investment that are also necessary for creating a smart network to respond to also to the effort of improve the quality of the service and the resilience of the network. This is the area, no? So the scenario on the left side, and what is the perspective, because it's not just the content of the network itself, but also in terms of asset, but also in terms of the data that we will face to manage. So more and more you will be capable to monitor the network in real time, and more the volume of data that you need to manage is incredible. More and more the typology of customer need and typology of customer behavior will be differ, and more the interaction, there will be not just a boundary between the network and consumer, but there will be a extended, let's say, network up to the customer need. Appliance for customer will be, in any case, a component of the network, at least in terms of interface. So there will be not just the need for the network, but you need to accomplish or to their behavior, to their need. And also is a question how the worker in the network will change their capability and will be able to manage the operational side with the digital extension. So we are speaking about visor, we are speaking about capability also to train the network operator, differing, let's say, the real operation with the augmented reality or virtual reality in digital twins that will help also to improve not only the capability of the network, but also the safety for the worker. So this is very important, and also will improve their ability in terms of know-how. So also the appeal to work on the network will increase, because the work will be more projected on the futures. So what the network will need. So I was mentioning before, there will be not anymore a distinction. So the communication layer will be the layer that's the fixed and mobile components will be part of it. So we will see here the services that are necessary for a network operator, and the typology of layer of communication layer that is necessary to respond to that in terms of requirements. So more we amplify the ability of the network to respond in due time, in real times, with more sophisticated appliance in terms of observability of the distribution energy resources from one side, or of customer capability of responding with necessary level of automation, and also remote assistance. That means efficiency side, or we mentioned before also the safety side. Sometimes remote assistance is also needed because we are facing to comply with a different resilience environment. And sometimes the extreme events also imply that you need to respond remotely, because there are not access in some situations. This is very important. So anytime you need to design the service for the network, you need to take in consideration not just the simple scenario of how the volume of electrification consumption will increase, or the volume of distribution energy resources will increase in terms also of amount, but also the condition that you need to face. So, and this is imply also that you need to respond to environmental constraint that more and more are increasing probability and intensity of climate events. And this is why you need to have services to respond to all of that. And as a consequence, you need a bandwidth requirement that is responding in due time in terms of volume, in terms of possibility that you have it on field and you have it on able to do that. And this is why we are here to speak about also 5Gs that, as you can see, will cover a larger and wide services that you have to do. This is the commitment we have in terms of how we need to respond to that. So we are why, so the real-time management, the mitigation of the aging of the infrastructure that is there, and we are speaking of distribution and transmission infrastructure at an average age in Europe of more than 40 years. So it's something that you need to adapt. You cannot have all the money and all the time to create a substitution immediately, but you need to accompany that. You need to predict more and more the flow if you want to face also the change of the energy market. We have seen now also the Ukraine war has changed completely the paradigm of the energy flow. So more and more the needs of having an energy flow coming from the distribution and was not just a need for the transition and to accompany the net zero objective, but also a need that has to be anticipated because you need to have the capability of for your supply of energy to adapt also events like that. So this is very important. The safety improvement we were mentioning is last, but I think is the first thing. So you need to think that how you need to respond for the digitalization to improve the safety in terms of operation and in terms of also prediction. So what you need to do to respond to that? Advanced emitter infrastructure is already there. We have been front runner on that. We have the second phase of full implementation on the Italian territory. We are near also on the Spanish one for the second wave of smart meter. But you need not just the metering, but also a metering infrastructure. That means also to accompany the entire capability of measuring, let's say, the network with the real-time observability. You need sensors more and more that are embedded on infrastructure, and you need also to have data centers that are future-proof in the meaning that could respond to the change and to the challenges that are not just the ones of nowadays. How you do that? For sure, the data boundary is very important. You need to manage this lake of data and have also the possibility to share the analysis of data in the sector in order to have a common improvement. So the improvement is not by a sole company, but is on the sector, because you need also to improve the capability of the sector to respond, supply chain, and also empower, let's say, employee in order that they are able to do that. You need an artificial intelligence solution, and you need also protocol, because if you are speaking about interconnection, you need also to understand how to protect that data for customer, but also the entire network system that will be more and more sophisticated and more sensible to cybersecurity challenge. So these are the characteristics to respond to that. So where we are today, we already have this general, let's say, status of the network in terms of layer of controlling, automation, smart metering, video surveillance on the different main component of the network. but also you have a lot of things that you need still to be done. So we are work in progress as a company, but in general as a sector. But we need to improve on that and to raise the capability of the single asset of the network and the single, but also in terms of common improvements of for each layer of an infrastructure. So that's it. I hope that this project could be not just the sole one, but could be one of the layers for understanding how to conjunction, let's say, network and layer of telecommunication, and could create also additional work on that. Thank you so much.
Thank you, Viviana. And let me call my colleague from Wintre, Luca Monti, to talk about telcos and what's going on, because we saw the energy and what are the next need in terms of digitalization, and let's see how telco is preparing to answer to those needs. Thank you.
Okay. Thank you so much. Thank you for having me here. Let's go through a very short overview of how the telco industry is looking at these new opportunities that are linked to the industrial IoT in general, smart grid applications that require this kind of mission critical capabilities from the telco overview. For those who do not know Wind3, we are an Italian operator. We are part of a larger group that is Hutchison Holding. So we are part of a group that is worth 200 million subscribers worldwide. We have a good history, a success story that spans over 20 years of history. We are now a fixed and mobile operator. We are active in FTTH, 5G, and everything is related to communication. We have also recently launched our FWA solutions. I'll tell you more about that because we are not only a telco operator. This is a change of skin that we are currently facing due to the fact that we have to make more money to gain sustainability in this telco sector that is becoming very difficult. A bit of context. These are some concepts that are mainly probably well known to you. We are going through a deep understanding of the fact of the importance of the digital infrastructure on both the consumer and enterprise. We have consumers that are eager in requesting bandwidth, low latency, even for the mobile gaming and other applications that are not currently correctly monetized also by the operators. So OTTs are providing this kind of services, and the operators is in like a dumb pipe that has just to provide the capabilities for free. And obviously, as you know, the customers, the consumers asking also discounts typically on this kind of 3, 4, 5 euros per month, and for them it's also too much. So we have this kind of issues on the consumer side. On the enterprise side, all the operators are trying to tackle the opportunities in the industrial IoT and all those verticals that require this kind of data processing that is closer to the customer, to the premise. And the smart grid itself is an example of this kind of applications. The high availability, the secure connectivity require massive investments. That is something that probably is not well understood by all those players, OTT first, hyperscalers that are trying to use this kind of connectivity capabilities, at least for free or in a joint opportunity development that typically underestimate the effort that is required on the telco operator's side. So that's why the telco operators are expanding the offering, going beside the typical internet-centric proposition, either for consumer and for business, entering new sectors. We are an example of not beyond the core, as typically we say when we talk about the services that improve and, let's say, enrich the typical connectivity basic proposition. But we are going beyond the telco, entering also adjacent markets such as energy, gas, and insurance. Bear for the Italian, but this is our billboard. We have recently launched energy, so we have entered the gas and energy market. That is pretty profitable because it's much more worth than the telco market itself. So obviously, it's a blue ocean for us. And also the insurances, assicurazioni. We are enter also the insurance market. So our shops now have this kind of billboard, so the customer can enter and subscribe either connection, energy, or insurances. So it was unbelievable 20 years, also even 5 or 10 years ago, that this would have been in future the perspective of a telco operators. But just to say that we are facing some economic issues. So when we talk about R&D, smart grids, MAC connectivity, and edge computing, we have to put that in the right perspective. From a mobile data and fixed data point of view, this is what we have to cope with on a daily basis. We have a growth of almost triple traffic in the mobile data in the last 3 years. We almost double the traffic on the fixed data. So this is something that is relying on the typical connectivity capabilities that are provided by a telco provider like us. I don't want to go into the details. I want just you to catch, to have a sneak peek at this kind of concept. This is a bit of financials, I will say. This is the mobile data comparison. You see on the left side, in Italy, we have dropped from $1.7 per giga to 0.1. So consider that in three years we have dropped this kind of cost for the customer, and pretty much the same is also happening on the fixed, even with a smooth decrease. But also in Europe, typically we are facing a growth and eager, aggressive, let's say, fierce competition in the market. This is also what happens on the overall value of the telco industry. Those are Italian figures. This is expressed in billion euros. We have lost, as a telco industry, mobile and fixed, 35% of value in the last 12 years. So this is the top line, These are the revenues. And then there are the costs. And said that the costs also are impressive, because we have to cope this kind of doubling and tripling the traffic. We have to cope the 5G licenses. We have to deploy the fiber, or we have to resell the fiber on the other side. So this means that the trend is becoming unsustainable. As you see in 2022, the financial that are subtracting the PDDA, the less capex, so the free cash flow, the dividends that are given to our shareholders are negative. So should you invest in something that is burning money instead of creating? And that's becoming a substantial and structural problem in Europe, and specifically in Italy. This just put in the right perspective what is happening in the telco industry. At the European level, there are other challenges, that we all know that the coverage is not to the extent that it might be probably expected since many years of launch of the 5G, because it's 5-6 years that we have launched, and we are more or less at 20% of populated areas coverage by the standalone itself. But we are talking about probably some basic deployments of exposure functions or network slicing, but without a very extensive deployment of the services and the vertical that they have to sustain the business. Or even the edge computing deployment is still very limited. Those are values taken from the white papers from the European Commission, so they're publicly disclosed. But we see a sort of takeoff in the mobile private network deployment. So takeoff worldwide, also sustained by some free range, free spectrum CBRS approaches that are in some countries being part of the overall project, but also in Italy, as Windray, we are deploying this kind of application in the smart ports environment, for example. And this was an example of taking to reality something that 5-10 years ago it was just a vision in the 5G deployment. So there is so much rain that have some good news at least. Okay, the convergence between cloud edge computing. We also have proved during this kind of exercise. I understand that we understood the importance of the software, of the knowledge, how can data science apply to data being generated by smart grids or the consumers itself, can be used to improve the operations and to also improve the customer experience. All these kind of competencies that are not relying on just on the network side and on the edge computing, but also relying on the evolution of the BSS, all the business support systems on the IT side. All these competencies are currently present in the tech operations. So we have to be optimistic, because as soon as the evolution toward the software is also demonstrated by this kind of application, we are there. So we are learning to master the smart grid, and for example, as an example. So this kind of mastering of the software is a good point for the future. The emergence of the new markets and the app economy, let's say, we can say that they are leveraging on the cloud computing. So in this perspective, all the experiences that we are doing, either in private networks or in the kind of smart deployments that are part of the smart grid project, for example, or the funded project in general, are a good example, and we should pursue that direction and that strategy, because we are going into the right direction. In general, this kind of complexity, where the infrastructure stakeholder work together to create this kind of network as a service applications and environments, are making easier for the deployments of application for the developers to contribute to the development of the services. So we see in perspective that this kind of partnership will be more important with the hyperscalers itself, that also play a big role either in the infrastructure deployment, for example, in the edge computing side, or in the marketplace of services. So we see that also in this direction. Is good that we are doing this kind of exercises, because we are going into that direction. The network slicing, just a few words about the opportunity. As said, we are, all the operators are putting efforts in exposing these kinds of functionalities that might be the basic functionalities exposed by the network exposure functions at the architectural level. But we understand that probably there is the need of having something that is decoupling layer in the middle, giving the ability to better expose and simplify the exposure toward the verticals, toward the services. I know there are some working groups that are taking care of that. We in the Smart5Grid, I understand that we are also looking at the possibility to work directly with the exposed functions in perspective. So this is an open point. We understand as an operator that this might be an opportunity to leverage on functional capabilities that are provided by by 5G, probably with some add-ons in terms of simplification of layers. But that's the direction. This is the opportunity that we shouldn't miss to monetize the 5G to full extent and prepare better for the 6G. We don't have the answers yet. Probably all the funded projects in general and this kind of working groups should also understand better how to monetize and to sustain the business model, because that's key. As said, all this kind of stuff requires a lot of money, a lot of investments. Without a proper sustainable business case, this cannot be achieved. Okay, thank you.
Okay, there is a bunch of money here. So before to start, let's watch a video together.
Energy grids require a reliable digital communication layer to handle the new challenges coming from distributed generation. The Smart5Grid project proposes the novel concept of network application, to simplify the complexity of 5G technologies and make them accessible for all the developers. The network application allows to adjust the 5G network's behavior to the user needs, having the core and user functionalities in the same cloud-native package. Being executed in the edge, network applications enable what we call 5G-based edge cloud computing, the open service repository and a verification and validation framework will support the developers in network applications implementation. 4 real-life pilots have been implemented to demonstrate the system. Smart fault selection automation framework needs a reliable digital layer to perform. A dedicated network application constantly monitors the digital communication layer. Safety is a priority in the power plants. The Spanish pilot implemented a safety monitoring tool using a private 5G infrastructure. The human operators are constantly monitored with 3D sensors and cameras to prevent accidents. "5G technology supports real-time remote monitoring and control of distributed generation. A series of sensors data and a historical database will support the creation of a predictive maintenance enabler. Real-time monitoring of the cross-border power exchanges taking place between 2 interconnected systems. 5G supports the real-time monitoring of the last mile of transmission grid. The project has been implemented by 24 European partners, coordinated by Enel Grids.
Okay. This was a short peel about what we did in the last 4 months. So I forgot to introduce myself. I'm Daniele Porco from Enel Grid, and I'm proud to be the project coordinator of Smart5Grid. So in the previous 2 presentations, we were facing with 2 reality, 2 infrastructure, the energy infrastructure and the telco infrastructure. So to achieve the goals of the grid, we need more and more digitalization. So what kind of digitalization are we looking for? Let's think about how the communication is happening between something in a control room and the field devices. So there is the telco infrastructure in the middle, and we are keep on improving the latency and all the telecommunication parameter, but it's nothing more than a telegraph. There is a sender, a receiver, and vice versa. We always forget that, let me go back. The telco infrastructure nowadays, it's a digital infrastructure. So if we can manage to enter inside the infrastructure and manipulate it to our needs, I'm talking as a energy grid person, it's opening to what we call 5G based cloud edge computing. So by inserting some computational capability, the so-called max server, we can virtualize a series of things, mainly sensors and devices inside the max server. So in this way, we can use cloud-native technologies to be managed across the telco infrastructure. And we can also, being executed inside the telco infrastructure, interact with the core network whenever it will be available, to adjust the grid, the telco infrastructure behavior to the grid's need. The project started in January 2021, if I remember right. It's investigating the use of 5G technology for energy grids and in general for energy vertical by means of the so-called network application. So network application is a way to simplify the complexity of a series of layers that we will see during the day to allow the access to new developers to this technology. So as we saw also in the video, we implemented virtualization layer that's allowed to execute code in the edge. But above this layer, there's a platform which enabling the implementation of the network application and a series of activities for the automatic test of this application. So in case I'm a developer, I want to implement something in the edge, I can use this facility, and we will see later on in detail, to quickly have feedbacks from the platform and understand if my code is working or not. This has been our long pathway. From the very beginning, we started to investigate the use case, how we can perform, and starting to integrate the pieces. The first issue has been about the language. It's just a curiosity about our big team, because everybody was talking about network. So we decided to split. Network is whatever is IP and infrastructure of telecommunication, and grid it's energy. So at least to split those two industry. But in the middle, there is all the information technology and telecommunication know-how. So we developed 4 pilots. Each of them are equipped or supported by a dedicated network application. Plus, we interacted with the 5G PPP, that is the public-private partnership with the European Commission and the industry for the implementation of 5G technology. 5G PPP finished its pathway in December last year. So all the knowledge implemented are now followed by the new frontier, the 6G. So there will be a new alliance and association, let's call it, just not to use the word container that I hate, but it's a new paradigm to investigate the new technology. So we will also talk about that. So as I mentioned, we developed a series of tools to support the developer in implementing those network application. Plus, we gave the opportunity to have remote assistance in case of problem, like developing the first ever network application for energy industry. It was maybe not that easy, so we went through also this kind of duty. As I mentioned, we are not the only project implementing network application. We are together with other 8 projects. Each of them tried to understand what was the real need from the specific industry. There are pros and cons. Like if you start from the vertical and understanding what is the need, maybe you are not converging to a standard, and this will be the challenge for 6G in the upcoming future. So, for the moment, I will stop it here. Let me call my colleague Helio Simeão that will talk about that platform. But before, let's start with a video.
According to Moore's law,
the exponential growth in the concentration of transistors in integrated circuit chips
makes computer hardware more and more powerful. Right. Today, a smartphone is 100 million times more powerful than the computer in the rocket that sent men to the moon, and can now easily replace the formerly used dedicated hardware. Except perhaps in the coffee machine. Nowadays, the same goes for network functions. From being linked to dedicated hardware, they become virtualized software that can be run anywhere. It's what we call Network Functions Virtualization, or NFV for short. And just as it was the case for music, video, and communications, the virtualization of network functions allows new uses and much greater flexibility. For instance, a natural disaster, a cyber attack, a spike in demand, or simply a system update. Virtualization allows the network to adapt instantly and even, why not, automatically.
Your updates are being installed.
Everything is becoming more flexible. A flexibility that is essential to build the networks of the future. Networks which must, of course, remain fully secure, reliable, and interoperable. So, at Etsy, we bring together an international community constantly expanding, with operators, manufacturers, IT and cloud players developing specifications and open source components for NFV essential for the world of tomorrow. Since 2012, Etsy has been the home of NFV. So, join us.
And what about virtualizing the coffee machine? When's that for, huh?
One day? Who knows?
So, hi everyone, I'm Elio. I'm a product owner at Ubiware, and we are virtualizing coffee machines. No, I'm just kidding. So, I think this more or less intertwines with what we've been hearing about from the speakers, that how there is no telco or energy infrastructure in the future. There will be a common infrastructure that will have a bunch of software and apps and running, and we somehow have to manage all of that. And this is, we're pushing into that direction. Well, I think I have my notes here. So anyway, so the goal is that, we are reaching this kind of merging, I guess. We have this, we can call it this OT realm, or operation technologies, right? So everything, for example, related with energy. That could be other industry. And then we have this kind of IT world that we can include all the cloud providers and so on. Thank you. And basically, these two are converging, right? We are basically transforming what is an OT problem into an IT problem, which usually it's complex, but it's solvable, right? So that's kind of how I think more or less all the industries are moving. And as we can see, so we've been kind of like the brain of the systems. It's been centralized, and it's becoming much and much more distributed. Of course, this brings new challenges. So, for example, when we have something very centralized, it's very easy to be managed. It's very controlled. The resources are controlled. If we think about a data center, right, it's super protected. It's not easy to gain access to. But if we think about maybe a primary, secondary substation, a pole, that's different, right? We have people can go there, can burn stuff, it's more access to the broad public, let's say. This brings challenges, of course. And these are some of the tools that we are developing that are made to help and facilitate the management of all of these, let's say, software and applications that will run the network for us, just like we saw in the video. So in essence, there's a concept of network app, which basically this links with the Etsy, or what Etsy has been doing as well, where Smart5Grid and the other projects, we are proposing, let's say, a standard, or let's say we are doing things this way. And if you want to collaborate with us, you can try this way, knowing that there are, of course, similar pathways. Basically, the idea is that we have resources that are on the cloud, that are on the edge, right? And for example, if we think about something that needs very low latency, like a trigger switch or something, you don't want to rely on the all end-to-end connectivity, right, in the round trip time, because something might break or might not be as fast. So you want the intelligence to be very close to the grid or to the devices themselves. So you want to place some software function, right, at the edge, closer to the to the devices themselves. But if it's, for example, a monitoring tool, well, maybe those resources can be at the cloud. And it's this decision that seems simpler, but it's complex. And how do you manage all of this together? This is some of the challenges, right? And so basically, no, just some, sorry, before, yeah. This works? Yeah. Oh, so I can, it's fine. I can, thank you. As I was saying, so, yeah, indeed. So the idea here is that, so from bottom to up, so we have this, what we call cloud edge continuum, right? We have basically a more efficient use of resources because, believe me, it's way harder to get more resources at the edge than at the cloud. At data center, you have infinite resources almost, while at the edge, with the constrained edge devices, it's not the same, okay? You can think, for example, a Raspberry Pi or an NVIDIA Jetson that basically will already have some, processing capabilities, but it doesn't compare to a data center. All of this, it can be reused. So whatever software, let's say, or if you break something complex into more manageable software parts, these are more usable to be reused, more usable to be managed. If something breaks, you can put it back up again and it doesn't, the whole chain doesn't break. This is the sort of paradigm that it's already super present in, whatever IT world, or if you want to call it, in a cloud provider. But in energy grids, in the telco domain and so on, this is still, making its steps. And of course, utilization of software. And for a developer, we kind of give developers a recipe that if you follow this, your app can speak with the network and the network can speak with your app. So that's kind of the advantages of collaborating with us. Okay. Yeah. Work. Thank you. So just a little bit more context. So now imagine, so not just a single net app, but a whole chain of network apps, which is basically it's some job that the network has to do, right? That can be linked to each other, that can be upgraded separately. This is very important, for example, especially if you think about energy grids. If you discover a bug or something, you really want to fix it very fast and to not break everything, right? So this is the sort of, let's say, software ways of managing things that it's super present, again, in the IT world, that can be applied very, not easily, but can be applied to the energy domain. So in this schema, for example, we have some let's say, networks or data networks. So some outside networks that can be accessing or need an access to an application that will be in the cloud. Others need to access to other functions that can be at the edge. And this linkage, let's say, it's what we can provide with such artifacts like the network apps we develop. So in essence, this descriptor is where the developer will kind of have to describe, okay, this is what we are building, and this is what basically let's say, if the developer speaks French and the network speaks, I don't know, English, this is what will make the translation, okay? And of course, on the bottom, you have like the hardcore requirements like CPU, network, RAM, and so on, and then you'll move on to a little bit more complex, such as interacting with other services, and this is where the reuse comes in play, okay? So that you can have pieces of software that are reused by a whole other chain of new functions, new network applications. Okay. So how can we help developers? So in essence, so the developer goes to his cave, starts to do some development stuff, and then he wants, okay, will this work in real life? Let's say. So they can come, or they can join us, and they can use our testing facility to verify the NetApp. This is a set of syntax, so more related with the like quality of the code. Let's put it like that in a very simple manner. The validation, it's a little bit more complex in the sense that it will actually deploy the network app in the testing environment that Smart5Grid project provides. And this has several different stages. I'm not going to go through them in a very detailed manner, but the goal is that in a testing environment, this runs. this is the type of feedback that we provide to the developer. So we give some hints on the verification phase about the quality of the code, and then on the validation, we can at least, in a very controlled environment, in a test environment, we can actually deploy your application. And then, of course, if need be, and this can already provide maybe a hint to some of the potential business models, for example, either for telcos, that you can provide, for example, a telco could have this sort of platform and could have kind of a catalog of network apps that these were validated. These were approved by us and these run in our network and you can use this. This is kind of to try and, again, telco world, the operators are making less and less money. I think it's 2G. We're not back in the 2G days where, it was very costly to send an SMS and to make a phone call. But there are some new challenges. And this is, for example, potential business models in terms around apps that maybe telcos can look at. And then, of course, this could be the network application can be available, for example, for others to use as well. So a sneak peek into our platform. This is the user interface, and basically this is what a developer will interact with. So in here you see several of network applications that we developed throughout the project, and all the different software artifacts and, let's say, components that make a network app that need to be uploaded and tested and so on. So just in short, so the idea of network apps is reusability, right? Is to make sure that you are doing something that is not only deployed fast, but also can be upgraded in a fast manner with new features, with improvements, but also that you can reuse it not only in this network, but in other networks, right? So if I'm a software developer, I don't want to make an app that only works for Vodafone or for whatever operator, right? I want to make sure that it runs on every network. Then, of course, we have the free testing environments. You can certify your net app with us. And I think this is a strong value proposition also, that it's not every day that you can get so many experts from different domains sitting together with one Teams call away. Yeah, thank you.
Thank you, Elio. Thank you, Elio. We saw on the one hand the hardware side, on the energy and the telco, and in the middle we have the software. So what was the topic about virtualizing we have a real coffee machine over there, so let's have a break and we continue after that. Thank you all.